Now, how about pre-stressed Hollowcore slabs? How do we put those slabs on top of steel beams? In this case, studs are already welded to top flange of the beam. And note one thing here, that there aren't any studs on this tubular section which you can see over here, which means that in case of Hollowcore slabs, we just use main beams which are oriented in this direction, in the direction of shear studs, and transverse to the direction of this beam. So we call this beam as main beam, and we call this rectangular hollow section as a tie beam. So it is not necessary to connect slab with this beam. Now you would argue, then why do we use this beam? And the answer to that is that
so how is the construction process different for each composite beam with solid hollow core, profile sheeting, and slim deck slab?
for showing the construction process, I will play these two videos which would make it really very obvious. I'm sure a lot of you would already know about it, but just as a refresher, I'm going to play these videos.
Composite floor slabs generally comprise profiled steel floor deck with in-situ concrete cast over the deck. The deck acts as permanent shuttering and spans in a direction transverse to the secondary beams. Primary and secondary beams in composite steel frames are rigidly connected to the floor slabs by shear studs, which are connected to the beams by through-deck welding techniques. This allows the floor slab and the beams beneath to act compositely. Beam depths are therefore less than in equivalent non-composite frames.
And I will play one for Hollowcore slabs as well.
For shorter spans, precast concrete floor slabs can be used with steel beams. These precast units may be supported on the top flange of universal beams or on the bottom flange of asymmetric slim floor beams, or ASBs. An ASB has a wider bottom flange, which enables precast units to be placed without clashing with the top flange.
Then first I will talk about beams with profile sheeting slabs or metal decking slabs. First, we bring profile sheeting on site, and this is the first step. And then we lay these sheetings on top of the beams, and the way we connect it with the beams is that initially we nail these sheetings to the beam, but certainly nailing will not provide a shear connection. So this is the first step so that they are in place. Secondly, we weld these shear studs through the sheeting to the top flange of a steel beam. So here you can see this is round shear stud or shear connector. This is a weld collar, and we weld these shear studs through the sheeting to top of the beam, and then you can see we get this configuration. The next step is we lay mesh reinforcement on top of steel deck. Now, what is the purpose of this mesh reinforcement? The only purpose of this mesh reinforcement is that this is used for temperature and shrinkage cracks. It is not doing any other thing at all. It is not providing tension reinforcement to the concrete because it's not at the bottom, it is at top. The only purpose is that we want to avoid those shrinkage cracks. Once this is in place, then we have in situ concrete. We pour this concrete on top of this deck. Now here concrete is being placed, and then at the same time it is being leveled as well. And once you level concrete, after that we compact this concrete using machine, and then finally you will have this surface on top. You wouldn't even realize that underneath that you have metal decking, and then after it hardens, then it is ready to receive service loads. Now, what type of profile sheeting do we have? Mainly, we have two types. One is trapezoidal decking. You can see this is oriented perpendicular to the axis of the beam, which means that it is a secondary beam configuration. And in secondary beam configuration, it is almost compulsory to use shear studs. In primary beams, it is not necessary, but in secondary beams, it is essential that we use shear studs. Another one is re-entrant decking. Re-entrant decking, again, shape is different, but the only limitation is that this goes up to probably 50 millimeter deep decking, while this one trapezoidal, it starts with 60 and then it goes to 80, and in some countries they have 100 as well, and in the UK we have about 150 decking, which has been recently released. Not recently, I mean it's in last 10 years. So these are two types of deckings that we use. Re-entrant decking is termed as dovetail decking as well in some countries. Now, how about pre-stressed Hollowcore slabs? How do we put those slabs on top of steel beams? In this case, studs are already welded to top flange of the beam. And note one thing here, that there aren't any studs on this tubular section, which you can see over here, which means that in case of Hollowcore slabs, we just use main beams which are oriented in this direction, in the direction of shear studs, and transverse to the direction of this beam. So we call this beam as main beam, and we call this rectangular hollow section as a tie beam. So it is not necessary to connect slab with this beam. Now you would argue, then why do we use this beam? And the answer to that is that we use these beams for structural integrity, structural robustness, and to prevent disproportionate collapse as well, which is another topic which we can discuss at some other point. So to provide that entire frame action in a structure, we use these tie beams. The only exception is that at the edge, it has to be composite, because we want to provide a frame action so that entire structure is connected together. But intermediate beams, they don't need to be connected, and we call this configuration as main beam and tie beam configuration. And the configuration that we use in case of profile sheeting slabs, we call it as secondary beam and primary beam configuration. Now here we bring these precast units on top of the beams. In this case, direction will be here, and once they are placed, then we pass reinforcing bar in between these gaps, and then we pour in situ concrete on top of that. In that way, it ensures composite action. Now underneath, it will look like this. Almost certainly you don't know what is happening at the top. And this is some of the testing that one of my colleagues, he did at University of Leeds when I was a PhD student. I was working on metal decking slabs, and he was working on Hollowcore slabs. And this was quite long testing. It was 20-meter beam, and they were testing behavior of composite joints. And again, you can see that it is quite large beam which was being tested over there back in 2010. The type of precast slabs, we have mainly two types, where we have no structural topping. We have these sections which we put on top of the beam, and then we pass this transverse reinforcing bar about 20 millimeter, and then we pour concrete on top of that. Secondly, we have this configuration, everything is same, except that we have structural topping by having some reinforcement, mesh reinforcement, and on top of that we have this topping. But no structural topping is more common in the UK, and I guess it must be more common in other countries as well. Now I have a question for you. What is the most used composite system in your region? I think I got the answer, composite deck. If there is any other composite system in your region, then put it in comments.
Deck slab. Then with metal decks and hollow
Okay,
core slabs. Yeah. Only one way design is possible. Two way design is not possible for slabs.
it is not possible now.
Yeah. Rib and block slab.
What is block slab?
He can mention in more detail what is block slab. One more response to cover steel column with RCC jacket.
Okay, jacketing. All right, excellent.